Alright, these are your notes for section 5.6 part 2, and this is still a continuation of section 5.6 where all we're doing is changing the way an expression or radical expression looks. Today we're going to focus on three different ideas: adding and subtracting radicals, which is what this video is about. We're also going to look at FOILing, which is multiplying, and then the idea of radical expressions in a fraction, which is the third video. But right now we're going to focus on adding and subtracting radicals. Now again, all we're doing is changing the way that the problem looks. We could put it in a calculator, the original problem, we'd get a decimal, we can put our answer in, we'd get a decimal, and those decimals should be the same, okay? With adding and subtracting, there are a couple things to remember. First thing is that your index and radicand must be the same. Now, when we multiplied radicals together, the only thing that had to be the same was the index. When we're adding or subtracting, the index and the radicand have to be the same. Okay? That's something to remember. Now, here are your steps. These next two bullet points are the steps. The first thing you want to do is you want to think of this as combining like terms. And your radicand and index are your terms. So anything that has the same index and the same radicand, they're considered like terms, and you want to combine them together. So what's going to be changing is the number out in front. The idea is like if I had 3a plus 2a, well, I had 5a's. This a didn't change. It's the same idea with radicals. I could have 3 square roots of 2 plus 2 square roots of 2. These are the same, so I get 5 square roots of 2. The radical didn't change. The number out in front did. Okay? So that's what I mean when we say combine like terms. You can think of it in that way. The last thing is that you may need to simplify first. And by doing that, you can get the same radicand. The index won't change, but you can simplify to get the radicand to be something different. Okay? So we got 3 examples here. We're going to do all 3 of them. And we're going to follow through these steps. We're going to make sure that we have the same index, same radicand, and I'm going to show you how to add and subtract radicals. So our first example here is 3 times the square root of 45 minus 5 times the square root of 80 plus 4 times the square root of 20. None of those at this point have the same radicand, but they all have the same index. So what we want to do is simplify them to see if we can get them to have the same radicand. So we're going to break down 45. 45 is 9 and 5. Remember, we want squares because we're taking the square root. Means I'm going to be taking a 3 out in front. There's already a 3 there, so 3 times 3, 5 stays underneath. That's going to become 9 square roots of 5. Our second one, now we want to remember to take the sign with it. We've got to break down 80. 80 is really 16 times 5. And 16 is a perfect square. Square root of 16 is 4, which means I'm going to be taking a 4 out in front. So now we have negative 5 times 4. 5 stays underneath. Negative 5 times 4 is minus 20, square root of 5. So far we have 2 of them that have the same radicand, which is good. That means we can combine them. We still have to do the third one. 4 square roots of 20. 20 will break down into 4 times 5. 4 is a perfect square. That means a 2 is going out in front. So now we have 4 times 2, square root of 5. 4 times 2 is 8, square roots of 5. So let's rewrite this over here. Now we have 9 square roots of 5 minus 20 square roots of 5 plus 8 square roots of 5. Now we're going to use that idea where we're combining like terms. They all have the square root of 5. So all I'm going to think about is the numbers out in front. So 9 minus 20 plus 8. Well, 9 minus 20 is negative 11, plus 8 is going to be negative 3. And then I put square root of 5 on the end. And there's the answer to the problem. Okay? Again, when we use this combining terms idea, we're not changing the radicand. We've already done that. We've simplified it to get it so that we could add and subtract them together. All we're doing is changing the numbers out in front. We have 9 square roots of 5 minus 20 square roots of 5 plus 8 square roots of 5. It's like saying I have 9 apples, I gave 20 apples away, and then I got 8 more. Well, how many do I have left? I'm 3 in the hole. So I have negative 3 square roots of 5. Okay? Hopefully that makes sense using the apples. I didn't want to confuse you. But all you're really doing is looking at the number out in front. Okay, let's look at our second example. Okay, our second example is the square root of 12 plus the square root of 48 minus the square root of 27. None of them, again, have the same radicand. They do have the same index, so if we can get them to the same radicand, we can add and subtract them together. To do that, we need to simplify each one. So to break down 12, be 4 times 3, 4 is a perfect square. There's nothing out in front, so it becomes 2 times 3 now, or 2 times the square root of 3. Now I said there's nothing out in front. There is a 1 out in front. Don't forget that that's there. That's important when you're adding and subtracting. Okay? It's not important when I'm just bringing a number out because 1 times anything is that number. So it doesn't change the number that goes out in front, but if I were adding and subtracting that radical, it would be important. Okay, let's break down 48. 48 is really 16 times 3. 16 is a perfect square, which means we're going to get 4 square roots of 3. Let's break down 27. 27 is 9 times 3. 9 is a perfect square. We've got to take the sign with it, so we get negative 3 root 3. Now we're going to combine these. All the radicands are the same, which is good. That's what we want. So we're just going to look at the numbers out in front. 2 plus 4 minus 3. Well, 2 plus 4 is 6, minus 3 is 3, so we get 3, and we tack on the end, square root of 3. And there would be the answer. Okay? Last final example for this video. We have the square root of 12 plus the square root of 150. Well, we just broke down the square root of 12. It's 4 root 3. You'll see that one a lot. That's one that if you see it, you might be able to just remember what it is. Not 4 root 3. Well, see, I made a mistake. Just don't listen to me for that. It's 4 times 3, which is 2 root 3, okay? If you're going to break it down, you're going to memorize it. Make sure you memorize the correct thing. So we got 2 square roots of 3. 150, we need to break that down also. To break 150 down, it's really 25 times 6. 25 is a perfect square, which means we're going to get 5 times the square root of 6. Now, the reason we did this example, even though we simplified them, they don't have the same radicand, so they cannot be added together, and this would be your answer. Okay, we leave it at 2 square root 3 plus 5 square root 6 because they have different radicands. You do need to simplify it to make sure that they don't have the same radicand, or that you could get the same radicand, so you do have to simplify it. You do need to do that step, but once you simplify it, we can't combine them, so we would stop here. Okay, so these are your notes for section 5.2 or 5.6 part 2 on adding and subtracting radicals. If you have any questions, rewatch the video or bring them to class next time.